Good morning, happy Friday. So this is our part two of writing expressions in factored form lesson, and we're going to talk about something slightly different that happens. It shouldn't be too crazy for you guys. If you got yesterday's, I'm sure you'll get today's. The real difference is there's just a couple more options to consider when picking out numbers. So we're going to list the pairs of numbers that multiply to get negative 12. So go ahead and just start off by doing that. List the pairs of numbers that multiply to get minus 12. So you'll notice here we're now getting a negative number as a result, which means that our factors must be one positive and one negative. So we're going to have one positive and one negative number. So that means that we can have either like 12 times negative 1 or negative 1 times 12. Or I could have maybe 2 times negative 6 or negative 2 times 6, 4 times negative 3, or negative 4 times 3. That's just as our 6 real options. So now we're going to think about the sum or the difference. So last lesson talked about like things that add to 20, but maybe they multiply to get like 6 or something. So we have to think about now which of these pairs have a positive sum and which ones have a negative sum. So add your numbers together, which ones are positive, which ones are negative. So that positive sum, put that in dark. I'll put that in green because green is typically positive numbers. And I'll make negative sum like, I can't make it red. I guess I'll make it orange. So let's see, 12 plus negative 1 is a positive sum. Negative 2 times 6 is a positive sum. And 4 and negative 3 gets us a positive sum. And the other ones all give us negative sums. Wait, that's supposed to be negative 12 and 1 up here. So negative 12 and 1 give us a negative sum. 2 and negative 6. And negative 4 and 3 give us negative sums. So it's important for us to realize that if the negative number is larger, we have a negative sum. And if the negative number is smaller, we have a positive sum. Okay? So we're going to think about that as we go into our lesson today. Okay, so these expressions are like the ones we've seen before in yesterday's class. So take a minute now and make sure you are able to go from factored form here in my left column into standard form on the right. And then see if you can go from standard form into factored form. And remember, think about the two numbers that multiply to get you your last number and add to get me that linear term. So go ahead and see if you can figure out those examples there. And then I'll post the answers in just a second. So hopefully going from factored form to standard form is just very straightforward at this point. We should end up with x squared plus a 5x plus a 6x plus 30, which simplifies to x squared plus 11x plus 30. And remember, we want to keep noticing that the two numbers being added to x multiply to get the constant term of 30, and the two numbers being added to x add to get the linear term, just that 11x term. That's a pattern we want to recognize and keep seeing happening, even as you go from factored to standard and backwards. And then going from standard form backwards, I notice that again I need two numbers that multiply to 30, but they have to add to get me 13. So if I run through my factor pairs of 30, I can think of, well, let's see, there's 1 times 30, there's 2 times 15, there's 3 times 10, there's, let's see, 4 does not work, 5 times 6, and now that I've reached 6 again, these are my 4 pairs. So which of those 4 pairs adds up to 13? And that answer is 3 and 10 is my lucky winner. So that's how I know that my factored form expression must be x plus 10 times x plus 3. So then we have our next one. Again, multiplying out factored form should be x squared. We have negative signs here, so we have negative 6x and a negative 3x, which combines to make a negative 9x. So again, negative 3 plus negative 6 gets us negative 9. And then negative 3 times negative 6 gets us a positive 18. So then my next one down here, going into factored form again, x squared minus 11x plus 18. I need two numbers that multiply to get me 18, but add to get me negative 11. So I'm going to try to put all this in one area. So now I'm going to have 18. I'll list my factor pairs for 18. So then at 18, I'm thinking, well, all right, my factor pairs are 1 and 18. 2 times 9 gets me 18. 3 times 6, 4 does not work, and 5 does not work, and 6 times 3. So I only have 3 pairs for 18. And which one of those adds to get me 11? Well, negative 11. So that means I have to use some negative numbers, which means I have to consider negative 1 times 18, negative 2 times negative 9, and then one of these pairs will get me the negative. And yeah, if you notice that 2 times 9 gets you positive 11, then yeah, you just want to make both of those negatives, and that's the pair you're going to use for that one. So that's why we have x minus 9 times x minus 2. So today we're going to look at things that look very slightly different from here. They look different because down here in the second table, we're going to notice something different that happened down here. And that is that the end term here ends up being a negative number. It's two numbers that multiply to get you a negative number. It's not crazy different in what it adds, but it does add more options for expressions that we can get for factored form. So I'm going to start by giving us our going from factored form to standard form here. So I should get, let's see, x squared. Then let's see, I have minus 3x plus 12x minus 36. So notice I have the two numbers that multiply to get me negative 36. I'll keep doing that in purple. And they add to get me 9x. So those two numbers add to get me 9x. Because negative 3 plus 12 is 9. So I have a positive 12 and a negative 3 that add to get me positive 9. So now we want to think, and all these ones are about 36. All of these expressions have the number 36 in them. So we want to think of all the numbers that can multiply to get negative 36. And we'll see how many more options this adds for us. So this adds for us, let's see, we can do 1 times negative 36, or negative 1 times 36. We can have 2 times negative 18, or negative 2 times 18. We could have 3 times negative 12, or negative 3 times 12. 4 times negative 9, or 9 times negative 4. 5, 6, 6 times 6. 6 times negative 6. And that won't change if I do a different way. So here's our options. We have all of these options available to us. So we have to think about which pair adds to get me negative 9. And I'm going to do different color highlightings for this. So which pair adds to get me negative 9 here? Well, first of all, I noticed that plus 12 and minus 3 added to get me positive 9 up here in yellow. But you can't see that. So the plus 3 and the plus 12 and the negative 3 add to get me positive 9 up here. So in order to get a negative 9, I just have to switch that. that'll be x minus 12 and x plus 3, because negative 12 plus 3 gets me negative 9. So there's that one. And then you want to think, all right, well, what if I have x squared minus 35x minus 36? Again, I need a positive and a negative because you're multiplying to get to negative 36. And what two numbers add to get negative 35? That is going to be, no, I want yellow, I want green. No. Green. 1 plus negative 36 gets me negative 35. So I should have x plus 1 times x minus 36 for that one. Now for my next one, which pair of numbers multiplies to get negative 36 but adds to get positive 35? That would be, hopefully you recognize it fairly quickly. That's a terrible highlight color, but we'll deal with it anyway. Negative 1 and positive 36. So I have x minus 1 times x plus 36. So it doesn't add too much to the mix, but it does add something else to be mindful of. And that if your last term is a negative, if your constant term is negative, you have to make sure you have one positive root and one negative root. Okay? So let's see what else we have here. I might reformat this. Give me a sec. Okay, so this is the last little bit of practice we're going to do for today. And then you'll have just your form to complete, and then you'll be done with math for another several days. So this is just going to be a bunch of practice. So look at 4 through 7, just some fill in the blanks, what goes in these boxes. We want to make sure that we fill in the blanks so that each line has a pair of equivalent expressions. So basically, here you're going to fill in the blank with a plus or minus symbol for 4 and 5. Number 6, it wants you to fill in a number. And 7, you got to fill in a sign and a number, so an operator and a number. So go ahead and take this time to pause it, see what you can fill in, and then we'll sort of walk us through each problem on its own. Okay, so I'm looking for here is really, for number 4, I'm looking for, well, I have it in factored form. So I'm going to look to see what's going to happen when I multiply this out. So I'll get an x squared, I'll get a negative 17x plus 1x. So negative 17 plus 1 is going to get me a negative 16, which means that I need a negative sign there. And then over on the right, it's going to be a plus 1 times negative 17, which is again going to get me a negative 17. So I need 2 negative signs up there. And then down here, when I have x minus 1 times x plus 17, when I multiply that out, I'm again going to get an x squared, but this time I'm going to get a plus 17 minus 1x, or plus 17x minus 1x, which will get me a positive 16x. And then the positive 1 times the positive 17 times the negative 1 will again get me a negative 17x, or negative 17 at the end. Okay, so changing one positive, one negative leaves that second term always negative, but it depends on which term is larger. If my larger term is positive, then my middle term ends up being positive. And if my larger term is negative, then my linear term ends up having a negative coefficient. So then here for number 6, we have to figure out what would actually go in my factored form here. So again, I want to figure out what factors would multiply to get to negative 28, but add to get me 3. And let's see, the factors of 28, let's see, I know from all my years doing math that 4 times 7 equals 28. So I can make one of them negative. Negative 4 times 7, 14 times negative 2, negative 14 times 2, but if I'm thinking while I'm doing this, I'm like, alright, well, negative 4 and 7 adds to get me 3. So I could think x plus 7 and x minus 3. Where's my 3? Why is there no 3 showing up? Oh, shoot. There we go. That was weird. So now I have a 3 and a 7. No, not a 3. 4. Dang it. So, yeah, so if I distribute all this out, I'll get x squared, I'll get a minus 4x and a plus 7x, which will get me a plus 3 over there. And 7 times negative 4 is negative 28. So that's where that comes from. And my last one down here, I want to think, all right, well, what factors multiply to get negative 28 but add to get me a negative 12? And now I'm glad I have all of these, because the ones that add to get me negative 12 are, let's see, I'll have it in gray. Negative 14 times 2 gets negative 28, and negative 14 plus 2 gets me negative 12. So I could do x minus 14. Oh, wait, x minus 14, and then x plus, these boxes are annoying to fill in the blank, 2. So there we have it. There's our blanks filled in. So now we're going to do a little more practice. So write each expression in factored form. So notice these are all 100. So we want to just go ahead and start by listing off all the factor pairs of 100. There's a lot of them, but you really need them for the first several problems on your exit slip that are similar to these. So feel free to, well, pay attention. So we're looking at 1 times 100. And then we're looking at, let's see, I'll go through negative 1 times negative 100. That's for positive 100. And let's see, so we have 2 and 50. Negative 2 times negative 50. Let's see, 3 is not a factor of 100. 4 times 25. And negative 4 times negative 25. We have 5 times 20. And negative 5 times negative 20. And let's see, 6, no, 7, no, 8, 9, 10. 10. 10 times 10. Then we have 10 times negative 10 times negative 10. And that's all of them. So we have 10 pairs of numbers for positive 100. And now notice we could also come up with 10 more pairs for negative 100. Because again, we have all these numbers, but again, with only one different number being negative. So here we're going to sort of start off, and I'm going to say, all right, I got x. Let's see. They multiply to positive 100 and get me negative 25. So that means I'm going to need one combination of numbers where they're both negative. So let's see, which of these numbers adds to give me 25? Bingo, 5 and 20. But I'm going to want negative 5 and negative 20. So x minus 5 and x minus 20. So there's that one. Multiplies for 100, adds negative 25. And now down here, for part B, I need to multiply to get negative 100, but add to get me 15. So I'm going to go ahead and I'm just going to write my list so that I have them all equaling negative 100. So I think it'll be easier to do the math with that. So I'm going to go ahead and change the color. Get rid of the numbers. Okay, so now we have -1 times -100, -2, notice making the other 10 negatives not going to change the pair at all, so I can just leave that and get rid of the other one. So now I need numbers that multiply to get me -100 and add to get me 15. So which of these combinations is going to add to get me 15? -5 and 20, there's my winner. X minus 5 and x plus 20. So there's that one. So I could just leave you alone to try C and D, which I think I'm going to, yeah, we'll just walk through them, whatever. But you should be able to do a lot of these on your own. You could even just sort of fast forward until we get to E and F, because E and F are sort of, they're different. So let's see, then the next one multiplies to get -100, but adds to get me a -15 instead of a +15. Okay, so for that one, it's going to be the same two factors, but flip-flop the signs, because 5 plus -20 is going to get me a -15. So I'm going to have me a x plus 5, x minus 20 for that one. And part D, multiplies get me -100 and adds to get me -99. I'm thinking -1 and 100 sounds good there. So I'm going to see x minus 1, I'm sorry, x minus 100, x plus 1. Because +1 and -100 will get me -99. So there is that one. So, E and F. Notice with E and F what looks different about these two problems. What's different is that there's no B term. There's no linear term. There's nothing where there's an x. There's an x squared and there's a number. So the thing we want to realize here is that I'm looking for numbers that multiply to get 100, but add to get 0. So for our first one, multiplies to get 100, adds to get 0. Let's look at all our factor pairs. Let's see. 101, -101. 2 and 50. 52, -52, 29, -29, 25, -25, 100, I'm sorry, 20 and -20. So I have nothing in that list adds to get 0. So it turns out that we have our first sort of thing that we cannot factor. So this is unfactorable. We have no solution to factor this. But that's not going to be true for the next one, because part F has something slightly different. So we're going to look at what numbers multiply to get 100, or what numbers multiply to get me -100, but add to get 0. So here's my -100 list. I'll copy that down again. And which factors on this list add to get 0? Well, -10 and 10. So this one is going to turn to x minus 10 times x plus 10. And I threw a couple of these problems out here when we were first learning how to multiply these these expressions together, just so you sometimes be aware that sometimes that middle term cancels out. Because when I multiply this out, I'm going to get x squared minus 10x plus 10x minus 100. And that middle term there gets simplified out because negative 10x plus 10x gets 0. So really we've seen this before, that this happens. And it happens when this last term is being subtracted and is a perfect square. And there's no b term. There's no linear term. So that's pretty interesting that happens sometimes. So just be mindful in those cases that there is a b term and that b term is 0, or that linear term has a coefficient of 0, and that you need some numbers that multiply to get the negative but add to get 0. Okay? So, just to summarize real quick, when you multiply two positive numbers or two negative numbers, that results in a positive product. So like previously, if the last term is positive, we need two positives or two negatives. But if we have a negative product or a negative constant term, we'll need a positive and a negative root. And it'll sort of change how we pick our numbers based on that. So you can read through the summary on your own. It'll be attached to the PDF with your notes. I'm not going to be like doing school today just for personal reasons. So if you have any questions, I might be accessible by email. It'll be very sporadic though. So I will get back to you as soon as possible. So like if your assignment's not done by tonight, it's not the end of the world. You have like 6 days till our next class. Like we can figure it out if you don't get your questions tomorrow or today. All right. So enjoy your class and have a good day. Enjoy your weekend.